Hello, hello. Yeah. Good afternoon, my dear friends. Good afternoon.
Good afternoon, sir.
Good afternoon,
Yeah, I
sir.
hope you can hear me. Yeah, that's good.
Yes.
Okay. So welcome once again. Today we are going to begin our journey by looking at Unit 5, Session 1 of our course, Introduction to Structured Program Design. Okay. Now, previously or so far, we have been walking through some basic program design principles, and we've been looking at what a variable is and what all of those key or constants and data types and all those things. Now, what we want to do today is to delve a bit deeper and look at control structures and understand what control structure is. Okay, we want to find out what is a control structure. If we say a control structure, what do we mean by program control structure? Okay, so we'll look at three important program control structures. We have sequential, we look at decision, then we look at loops, and then we will now go ahead and pick decision and look at the various types of decision control statements we can have in our program, which can be what? Single alternative, dual alternative, or multiple alternative. Okay. Then, if time permits, we'll do an example or two. But if we don't have enough time, we'll reserve the example for after we meet at our next meeting. Sorry. Are we okay? And so I will just, so that we can allow more people to join, I'll just ask if there is any question we have from our previous lecture or from the studies. I want to remind us that if you go to the LMS, you can just go to the discussion, okay? And then you can leave a question or leave me a message or leave some of your thoughts or some of the things that are bothering you about the material we have studied for the week. You can leave those over there. I always go back to them and then I try to answer as many of them as I can. But all the students are allowed to also comment and join the discussion on the LMS platform. Okay, so please, remember, there's always a discussion on the LMS platform for every unit. For every session we do, there's a discussion. So you can go there and then put your questions on that discussion. And then the other students and myself will try and answer your questions. And then maybe it will lead to more questions. And then we can keep answering those questions till we get to a point where we all understand each other. Okay. Now, I also want to remind us with this meeting, with this, that I have posted the assignment. It should be open. I think it was opened yesterday. Okay. So I posted it a long time ago. Okay. But I set a date for the opening. So it's currently open. You can download, get a teammate or a team member, and then you and your team member will work on something related, work on the topic or work on the work that we have in there. Okay, so I have I think two very important case studies. You work on the case study, you develop the program, you draw the algorithm, you draw the pseudocode, and then you bring the work handwritten to the face-to-face lectures. Okay. Is there any question? Any question from the previous lecture or from any thing that maybe bothers you? And then we can answer it quickly before we begin our lecture today. Any questions? No questions?
Yes.
Okay.
Sir,
Yes, sir.
good afternoon, sir.
Afternoon, sir.
Sir, please, like you said, are we to, with a division of the group, are we to get anybody or randomly, or you would create that for us, please?
Oh no, I don't know all of you, so I guess that it will be best if you can create your own groups of two people each. Okay, maximum two.
Okay, sir.
Okay.
Thank you.
Okay, any other? Okay, if there's no other, then we will go straight and then do our lectures, and then we will proceed. Now, let's go and then take a look at what a control structure is. So, a control structure basically is a way to the main way that programming statements, or the main category that a programming statement can be put into, or can be put into. Now, in programming, we can put our statements into one of three main control structures. Remember, we are doing structured programming. And in structured programming, we write our statements in a step-by-step way, or in a systematic manner. Okay, our programs follow one after the other. Okay, now if our program is going to follow one after the other, then you need to organize it so that the program logic or the flow of control will be correct. Okay, and so what we need to do is that we need to look at various control structures that can allow us to organize our program in that systematic or step-by-step way. Okay, so in programming, there are three main control structures. Number one, there is a control structure we call the sequential control structure. What it means is that the statements in this control structure are arranged in sequence. Sequence simply means the thing follows one after the other. Okay, so you go to statement one, then statement two, then statement three, then statement four, then vice versa. Okay, then decision control structure is also one group of statements. In decision control structure or selection control structure, what happens is that we are asked a question, and then depending on the answer to the question, okay, we can make a decision or a determination. Okay, so programming language statements that fall into this category allow us to ask the computer a question, and then the computer will use some logic to determine the answer to the question. Okay, it's just like you waking up in the morning and asking yourself, is it 12 or is it 1 o'clock? If it is 1 o'clock, join the Zoom class. But if it's not 1 o'clock, maybe go to church, or maybe go and get something to eat. So notice that for you deciding to join the Zoom class depends on the time being 1 o'clock. Okay, so in programming, we can write statements that can trigger the computer to join the Zoom class at 1 o'clock, or to do something else. Okay, those statements are what we call decision or selection control statements. Okay, then we have loop control statements. Okay, or sometimes we call them repetition control statements. Now, in a loop or in a repetition control statement, what happens is that we write statements that can repeat some action one or more times. So, for example, instead of maybe writing my names 7 times, so my name is Bernard. So I write Bernard, 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 Bernard 7 times. Okay, you can write that in programming. You can write Bernard 7 times. But what if I ask you to write Bernard 200,000 times? Notice that it is not logical to sit down and repeat. It's not logical to sit down and repeat my name, Bernard, 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 200,000 times. And hence, the need to have a way to repeat Bernard 200,000 times without the hassle of writing Bernard 200,000 times. Okay, and so that is why we have those statements called loop control statements or loop control structure. Are we okay? So let's quickly look at the next section. Okay, let me get rid of this stuff. Okay, please give me a moment. Let me attend to something. I'll get back. Okay, thank you very much. So sequential control structure, like or as I was saying earlier, when a statement is a sequential control statement, what it means is that the statements are written so that they follow in a consecutive order. Okay, the statements come one after the other. So, for example, I have this illustration on the right hand side where I have this box and then I have an arrow pointing to the next box in red. I have an arrow pointing to the next box in green. Just imagine that these boxes are programming statements. Okay, so statement one, maybe say hello. Statement two, maybe print your name. Statement three, maybe calculate something. Statement four, maybe do something. You see, so if the statements follow one after the other like this, we call this kind of arrangement sequential because the statements follow consecutively. There will be one, and then there will be two, and then there will be three, and then they follow one after the other like that. Okay. So in the illustration here, we see the first statement, then we go to the second statement, then we go to the third statement, then all the way to the last statement. Okay. When the statements are written like this, that is when we call this sequential control structure. I hope everybody is clear about it.
Yes, sir.
Okay, so our class is very small class. Okay, so please, if you don't understand anything, kindly let me know. Okay, so I can help you. Okay, I would hate for you to go without understanding. Okay, okay, so that is that with the sequential. Okay, then we have another group of statements we call decision or selection control structure. Okay, so like as I was saying earlier, in a decision control structure, we want the computer to make a decision. And so what we do is that we ask a question. Okay, when we ask the question, based on the answer, whether the answer is a yes or a no, remember the answer can be, the yes can also be true and the no can also be false, okay? Because computers have a data type we call Boolean, okay? So we use Boolean pretty much for this kind of thing, okay? Where we ask a question. Now, when we ask a question and the computer determines that the answer to the question is yes, the computer will take this route, okay? And then we'll run this code. And then the computer will now go out using this arrow. Notice that when the answer is yes, the green one is not the only thing that is running. We done it. We done it.
And you were mentioning algorithms.
Well, which people are those?
The
Sorry.
programmers.
Okay, so here the computer makes a determination based on the question that is asked. Now, when the answer to the question is true, we only do the green box and then we exit. But when the answer to the question is not true, let's say presumably the answer is false, then we have to pass here, do the red box, okay? And then we here too, we also go out. Okay, so notice that only one of the two will be run. Either the answer is true or the answer is false. I hope you understand that. Statements that do this are the statements that we classify as selection or decision control statements. Okay? Are we okay, please?
Yes, sir. Yes, sir.
Okay, that's very good. Okay. Now, let me clear this. Okay. Okay. So now, what type of statements allow you to do this? Okay. Now, in programming, the type of statement that allow you to do this is called if statement. Okay. I know that the name sounds a bit off. Okay. But Yeah, the statement is called if. Very soon you see how it works, okay? So we have several types of them. We have something called the if-else, okay, statement. So there's an S and then there's an E, okay? We have an if statement, we have an if-else statement, and we have something called the if-else-if statement, okay? Then we have another statement called the switch case statement, okay? So they are the ones that allow you to ask a question, and then based on the answer or the response to the question, we can either go one way or the other way. Okay? Then we have statements which sometimes, okay, so let's look at some examples. So we have the single if statement. So you can see the if statement like this. So usually when we write it, we write the if statement and then there will be a Boolean condition, right? Remember this condition over here would be Boolean, okay? So this one will be Boolean. When we say something is Boolean, it means it can return what? True or false, okay? So the condition will be a question so that the answer will either be true or false. Now, if the answer is true, we come and do this one, okay? And then sometimes we can write it in a box or in a format we call the if-else. This one is called the if because notice that there's no else, okay? But this one is called the if-else, okay? So you see that over here, it's almost the same, but just that there's another box down here, okay? So notice that here, we check the condition. If the condition is true, we do this one. But if the condition is not true, then we do this one, okay? So here we have something for true, something for false. But over here in the first one, we only have something for what? For true. Okay? So if you want to do true and false, this is what you use for true and false. But if you want to do only true, this is what you use for only true. Okay? Then we have something we call the if statement. So this one is when you want to test multiple things. So you have multiple conditions you want to test. Okay? Like in your assignment, we have multiple conditions. Okay? You want to test multiple things. You look or you use the if statement where you can check this first condition. If the first condition is true, that's the only time that you do this one. But if the second condition is the one that is true, then you do this one. And then if the third condition is the one that is true, then you do this one. Notice that in this kind of structure, you only do one of the three. You don't do all the three conditions. Okay? So these ones two are there. We call them if-else-if statements, and they fall under what? Selection or decision control structure. Okay, so you see some examples over here. If it is raining, then take an umbrella. Over here this morning it was raining. Okay, so we took an umbrella. So remember, over here, what it means is that if it is not raining, we've not written anything. The computer will not do anything. But the computer will only take an umbrella if it is what? Raining. Then look at the second example down here. If traffic lights equal red, then cross the road. Else, do not cross the road. So notice that over here, it's either the traffic light is red and we are crossing the road, or the traffic light is not red and we are not crossing the road. Okay? Then over here, if hours underscore work is greater than 40, then calculate pay, calculate overtime underscore pay. Else, calculate pay. So also over here, you can see that we are only going to do this two if this one is true. If it is true, we do this two. If it is not true, that is only when we do this one. Okay? Any questions? Hello? Are you hearing me?
Oh,
Yes,
sir.
yes, sir. We are following.
And you're okay?
Yes, sir.
Yes, sir.
Okay. Okay.
Sir, I have a question.
Okay.
So for the if else if, can you also say it's a nested if statement?
Well, it is not a nested if statement because it is a statement on its own. Okay, but every if else if can be written as a nested statement. Okay.
Okay.
But it is, remember, it's a statement on its own. There's a whole thing for it as well. Okay. Okay. Thank you. Thank you for the question. Okay. Then, not forgetting loops. Okay. So in programming, you can also ask the computer to repeat something for some number of times. Okay. So when you need to repeat something for some number of times, you use what we call the loop. So we've seen statements where you just want to write 1, 1, 1, 1 and stop. We call it sequential. We've also seen statements where we want the computer to check if something is true or false and then do something. Okay. Then we've also seen statements where we want the computer to repeat something for some number of times. Okay. So here, how do we go about it? So here we have several of them, several types. We have the while loop, we have the do while loop, we have the for loop, we have the for each loop. We have so many of them. We will explore them in this course, okay? But we want you to understand that if you want the computer to repeat in structured programming, we are going to use the repetition or the loop control statements or structures. Okay. Now, in order to do the true or false and to get it well, you need to understand relational or comparison operators. So in programming, the comparison operators are 6. We have the equal to. We call it the equivalence operator. We have the not equal to. Okay. We have the greater than sign or the greater than operator. We have the less than operator. We have the greater than or equal to operator. And then the less than or equal to operator. Okay. So these ones are what we term as the relational operator. Oh, okay. Mr. Gilbert had a question. He says, can you explain how an if-else statement works when there are multiple conditions and how the computer chooses which block to execute? Okay. So Mr. Gilbert and his friends, I'm going to explain it very well as we go along, okay? I actually will take it one by one and then we'll go over it one by one, okay? So I'll explain how it works, okay? Okay. Then if you want to combine the logical operators in programming, we use what we call logical operators, okay? So we have the AND operator, we have the NOT operator, we have the OR operator. It's very easy. Let me show you. So for example, if we pick 6 is less than 7, or less than or equal to 7, sorry. So from from mathematics, we know that 6 is less than 7, okay? So the answer is what? The answer is what? True. But if you do not of true, how not works is that not turns any true into false and every false into true. So because the answer was true, not will turn the true into what? Into false. Okay? Over here. Do you understand that? Hello?
Yes, sir.
No. Yes, sir.
Okay.
Yes, sir.
But do you understand that?
Please no.
Oh,
Yes, sir. Yes, sir.
do you remember that there was a sign like this in JSS or primary school? Like that?
Yes, sir.
Yes, sir.
Yes, sir.
So the gentleman who said no, I want to explain it to you. Okay. So what's the answer for this one? Hello, is it true or false? Is it correct? Is it true that 6 is less than or equal to 7? Or it's not true?
It's not true, sir.
Hey,
That is true. It's
who
true.
is saying it's not true? Hey,
Sorry, it's
hey,
true.
hey. Please, who said that?
No, it was me, please. It's
Okay,
true.
it is true. 6 is less than. When you are counting, okay, on the number line. Notice that you count 1, 2, 3, 4, 5, 6 before 7. So obviously 6 is less than 7. Okay, so because this is less than 7, the answer is what? True. Now, what not does is what I have in the table over here. Okay, so for not, if you have true and you do the not of true, you get false. If you have false and you do not of false, you get true. So because this answer was true and we are finding not of the answer, which is not of true, you get false based on the table. So do you now understand it, my dear friend? Who
Yes,
said
sir.
no? Okay. So over here, what will be the answer? Is A greater than B? The answer is false. A is not greater than B. B is rather greater than A in asking. Okay. Now, because we are finding the not of the answer, then the final answer will be what? Will be true. Okay, because the answer was what? False. And the not of false is true. Then here we are asking, is 13 the same as 13? Is 13 equal to 13? Can someone answer me? Is 13 equal to 13?
True.
Yes. So the not of true is false.
False. Yeah.
Thank you. Thank you. Then here we are checking, is 10 not equal to 89?
True.
Sir.
True.
Yes. So
It's
10
true.
is not equal to 89. So the not of true is false.
False.
Yes. Thank you. Thank you very much. Okay, so that is that. That is how the not operator. Okay, usually we write exclamation sign. So we write the and then we put the. It's called the not operator. That is how it works. If the thing is true, the not of true will be false. If the thing is false, the not of false will be what? Will be true. Are we okay?
Yes, sir.
Okay. Now let's go to the next one. So the next one is on our slide is the AND operator. So how the AND works is that you take two things. Notice that the not operator only takes one answer, okay? But the AND operator takes two numbers, two Boolean values, okay? We are dealing with two Boolean values. So what happens that if the first one is true and the second one is also true, then the answer, the end of the first and the second is true. Okay? Then if the first one is false and the second one is if the first one is true and the second one is false, then the end of true and false is what? False. The end of false and true is what? False. The end of false and false is false. So we'll use this table to solve the problem of what? End. Okay? So please watch carefully over here. Now over here we have two relational operations. This first one is true. Everybody can attest to it that 14 is greater than or equal to 7. Okay, everybody agrees, right? Who does not agree that 14 is greater than 7?
Sir.
Everybody agrees. Thank you very much. Now, everybody agrees too that 24 is not smaller than 19. And so this one is what? False. Okay? Everybody disagrees. Then, based on the table, we have true, we have false. The answer is false. And so, based on the table, the answer is what? False. Okay? Then, second one, let's see. 12 is less than 100 is what? Is true. Then 7 is not equal to 17 is also what? True. Based on the table, true and true is true. So the answer is what? True. So that's how we solve. The AND operator question. Any questions?
Really understood.
No questions. Okay. No questions.
Please go over one last time.
Over which one?
The logical AND operator.
And I said that the AND operator, it takes two expressions. So here we have the four possibilities, okay? We have the possibility for the first one and the possibility for the second one, okay? So if we have true and true, the answer is true. We have true and false, the answer is false. We have false and true, the answer is false. We have false and false, the answer is false. This is what you will use in the future, now and in the future and forever, to solve AND operations. Okay, and I'm saying that over here, we all agree that 14 is bigger than 7. So the answer is what? True. But over here, we all agree that 24 is not smaller than or equal to 19. So the answer is false. So because on the table, true and false, the answer was false. So the answer, final answer over here was what? Was false as well. Okay, then over here, we have 12 less than 100 and 7 not equal to 17. So here, 12 is less than 100 is true. 7 is not equal to 17 is also true. So true and true, the answer is what? It's true. So that's it. Very, very simple. You just look at the table and then you solve. But of course, you need to know your greater than and your less than and those things. You need to know these kinds of things. It's very important, okay? Sometimes most of us get confused because we don't remember all of these things, okay? We've abandoned all of these things because we're not in GSS again, but it's very important here in programming. So please, you have to go back and then try and remember how these things work, okay? Any confusion or anything whatsoever is because we may not remember how these things work. But we have to remember how they work. Okay, the final one is the OR logical operator, which we can use to also combine relational operators. How does it work? For the OR, just like the AND operator, it also uses the two expressions or two operands, okay, two numbers, okay? Now, those two numbers, their combination can be of this form, okay? So we can have true, 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 false, false, true, and false, false. Now, if we have true or true, the answer is what? True. If we have true or false, the answer is what? True. If we have false or true, the answer is true. It is only when we have false or false that the answer is also what? False. So here too, this is how it is. Now let's do a practical example, okay? Now look carefully. 14 greater than or equal to 7. We know that the answer is what? Is true. But 24 less than or equal to 19, we know that the answer is what? Is false. But if you check the table, look at the table carefully. If you check the table, if we have true or false, okay, true or false, the answer was what? The answer was what? True. So we can say that the answer to this one is true. Understood?
Yes, sir.
Okay. Then 12 less than 100 is what? Is true. Then 7 not equal to 17 is also what? True. So true or true based on the table over here, the answer is what? Is true. So that's why we are seeing true over there. Okay? So it is only when it is false that the OR of the true expressions will become what? False. Okay? Let's continue. Okay? Now, let's pick the selection control statements and then try to understand them well. Okay, let's try to understand them well. How do we write selection control statements? Okay, so selection control statements, like I explained earlier, they are useful for writing selection statements. Okay, statements that decide on two or more things and do one of the two. Okay, now we can write it in three different ways. There are three different kinds of selection control statements. Okay, we have the one way or the single alternative. We have the dual alternative or two-way. We have the multiple alternative. Okay, in some books, You will not see the one way, two way, multiple, and those things. But instead, you see the if statement. They are also correct. You see for the dual alternative, you see the if else statement. It is also correct. Or for the multiple alternative, you see the if else if statement. This is also correct. Okay. Okay. Now, let's look at the flow chart for how these three statements can appear. Okay, so you can see in the first one, we have the flow chart for the single alternative. Single meaning that when we ask the question and the answer is true, we go and do only this thing, and then we come and exit. Okay, so if the answer is not true, we don't do anything. You see that there's nothing on the no, but there's something on the yes. Then for the dual alternative or the if-else statement, we can do two things. Dual means two things. We can either do one thing when it is true or another when it is false. So notice that green and red, they are two different things and they are on two different paths. You cannot do them both. You can only do one every time you ask the question. Every time you ask the question, you can only do one. But there is something for every case. Okay? Then we have what we call the if else if or the multiple alternative. Here, there is an option for every value. Okay? We call it the multiple alternative. An option for every value. This one too is important. Okay? An option for every value. Okay? So let's quickly delve into the whole thing and then we can understand how it works and then we can proceed from there. Okay? So the first one we will take a look at is called the single alternative or one-way selection control statement. Okay? Most books also call it the if statement. Okay, now the if statement is the simplest type of selection statement. Okay, the if is the simplest one. How the if works is that if the condition is true, the statements within the condition or the statements in the body of the condition are run. So we can write a lot of statements here, as many as we want. These statements are sequential, okay? They follow one after the other. Now, when the test that we want to check, the one that we are checking whether it is true or false, when or if the test is true, then we come and run the body of the statements. But if the check is false, we skip the body. We don't run anything inside the body. I believe we all understand the word skip.
Yes, sir.
Yes, sir.
So it means none of the statements inside the body will be run so long as the thing is false. But if it is true, we will run the statements, every statement inside the body. So please have this at the back of your mind. We run the statements inside a single alternative if the condition is true. But if the condition is not true, we don't run anything. We skip everything. Okay? So let's see some examples. Okay? If you have any questions too, we can resolve the questions whilst we look at some examples. So in the examples that we are seeing, in the first example, we are checking a variable called age. If the number in the variable called age is greater than 18, then we write eligible to vote. Notice that if you are not greater than 18, you are not eligible to vote. Okay, so here we don't do anything based on this type of selection statement. We don't do anything. We don't write anything. We don't say anything. We don't go and do anything else. No, we don't do anything. The only thing is that we only do something when the statement is, or when the condition is true. Second example, we have balance. If balance is greater than or equal to, how do you call it, amount. Okay, so here what it means is that your balance in the account has to be more than the amount you want to withdraw. If the balance in the account is maybe 1,000 Ghana, but you want to withdraw 10,000 Ghana, this part of the program should prevent anybody from withdrawing more than the required amount. Okay, so this is also a typical example. Notice that you are only allowed to withdraw if this is true. Okay, if this is not true, you will not do any withdrawal. Okay, the program will end. Then in the third example, score is greater than or equal to 90. Here too, we are checking whether the variable or the container called score, the contents are more than 90. If the contents are more than 90, we set grade equal to what? A. So grade A is 90. Okay? Then, but if the score is less than 90, we don't do anything in the program we are seeing over here. Okay? We don't do anything. Then last but not the least, in the examples, we have number is less than 0. If number is less than 0, then we negate number and we put the number inside number. Okay, so we make number positive. So for example, if the number was what, maybe minus 3, okay, what will happen is that we will do negate 3, right? And so the answer will be what? If you do this, what will be the answer? Hello?
Positive 3, sir.
Pardon?
Positive 3.
Positive 3. Thank you very much. So the answer will be positive 3. Thank you. Okay, because negate, and then you get po. Okay. So, and these are the simple examples I'm illustrating with the single if statement. Yes. Any questions? Is this one clear?
Yes, sir.
Yes,
Clear,
sir.
sir.
So can we write a simple program that checks if a number is positive or negative? Okay, let's do the case where we are checking if the number is how do you call it? Positive. How would you check if the number is positive? What would tell us that a number is positive?
If
It's
the
greater
number
than 0.
is
If the number is what?
Greater than 0.
Yes, thank you very much. So if we were to write it, we'll write if, okay, we'll create a variable. Let's say the variable is called x. Okay, so we create a variable called x and we check if x is greater than 0. Then what do? We write the things we want to write. Okay, and then we end our program. So notice that this program will only do the things inside if x is greater than 0. Okay. Are we good?
Yes, sir.
Okay. Okay. So let me clear this and then we can go. Then somebody says, oh, sir, but this one doesn't do anything reasonable. How is it that we are only doing something when it is true? What if we want to do something too when it is what? Not true. Okay? So what if we want to check whether the number is positive or negative? Okay? So in that situation, we need to use what we call the dual alternative. For the dual alternative, what is happening over there is that in the dual alternative, we have two options. the program can either check the thing, okay, check whether the thing is true and do the first option, or if the thing is not true, then it is false. And so we do the second option. Okay, we call that the dual alternative. And the code or the statement we use for the dual alternative is called the if-else statement. Okay, if-else statement is what we use for the dual alternative. So here, what happens is that if the thing we want to check is true, we do the first one in green. Okay, we do the green one, and then we go out. Okay, but if the thing we want to check is not true, then we do the red one, and then we go out. So notice that if it is true, we do only one thing. If it is also not true and it's false, we also do another thing. We don't do them both. We only do one of the two things that we are looking at. Any questions? Is it properly understood?
Yes, sir.
Okay.
Yes, please.
Pardon me?
It's well understood, sir.
You have a question?
Well understood, sir.
Oh, okay, that's good. Okay. So let's look at the examples of statements that are considered as dual alternative. Okay, before then we can look at the syntax. So the syntax describes the rules for writing a dual alternative statement. So if you want to write a dual alternative statement, you are writing almost the same thing that you wrote in the if statement. You look at this carefully. It almost looks like the same thing we wrote in the if statement, but this time around, notice that we've added another part. So the second part down here is for the false. Okay? So the first part up here will do the true, whilst the second part down there will do the false. And like I said earlier, only one of the two will be done. Only one of the two will be done. So let's look at some examples, some practical examples, okay? So in this example, we have, we are checking hours. We are checking hours, okay? And then we have a variable called hours. Hours contains a number, and we are checking whether the number inside the variable is greater than 40. If the number inside the variable is greater than 40, what do? We calculate overtime hours, okay? Or overtime wages, okay? So we calculate your regular wages, and then we add the overtime, okay? Now, if you didn't work more than 40 hours, it means you worked within 40 hours. So if you work within 40 hours, then we are supposed to give you your regular pay. So you earn overtime pay when you work more than 40 hours. But if you don't work more than 40 hours, then you worked 40 hours and below. And so you should earn the regular pay. Okay? So notice that over here, only one of the two will be true. Did you work more than 40 or did you work less than 40? You couldn't have worked more than 40 and less than 40 at the same time. It's not possible to work more than 40 and less than 40. And then we illustrate this in the flow chart you are seeing. Okay, so in the flow chart you are seeing, you can also see that when you work more than 40, you go and do the green box and then you exit. And then if you work less than 40, you go and do the red box and you exit. Okay, is it understood?
Yes, sir.
Understood, sir.
Yes, sir, it's understood.
Okay, thank you. Thank you very much. So I have more examples. Okay, So in the next example, you are seeing that the first example, you are seeing that I have a variable called amount. We are checking whether amount is greater than 0. If the amount is greater than 0, then we calculate profit. And profit is equal to what? It's equal to what? The revenue minus the cost. And then we write the profit. Okay? But if the amount you have is less than 0, okay, it's not greater than 0, it means it's less than 0, then you do the else. What do we calculate? We calculate loss. And loss is equal to what? Same revenue minus cost, but will give us a negative value, okay? And because it's a negative value, we want to convert the negative into positive. And so we multiply by negative. Are we good? Are we good? Hello?
Yes, sir.
Are we good?
Yes, sir.
Yes, sir.
Okay. So, what we want to do is that we want to check multiple things. So we are checking the variable score. And in the third example, the variable score, we want to find out whether score is greater than or equal to 90. Okay, so what it means that we want to check what is inside score. If the value inside score is greater than or equal to 90, then we write passing. But if the value is not greater than or equal to 90, then we write failing. Okay, so for example, I want to ask, what happens if score is equal to maybe 80? What do we see? Do we see passing or failing?
Failing, sir.
Thank you very much. We see failing. Okay, thank you. Thank you so much. Okay. It demonstrates your understanding. You understand what I'm talking about. That's good. Okay. Last example down there. Okay, so in the last example, we are checking a variable called age. And if age is greater than or equal to 18, then we write eligible to vote. If not, then we write not eligible to vote. So, for example, if age is equal to 21, what do we write? Do we write eligible to vote or not eligible to vote?
Eligible to vote.
Okay. However, what if age is 16?
Not eligible, sir.
Thank you very much. Not eligible to vote. Thank you very much. Okay. So it demonstrates that you understand what we are talking about. Okay. That's good. That's good. I'm very happy you are understanding it. So let's delve a bit deeper. Let's delve a bit deeper. Okay. Since you're understanding it now, let's delve a bit deeper. Now, when we began, one of the gentlemen said or was asking about nested selection statements. Okay, one of the gentlemen was asking about it. And basically, when we say nested, what we simply are saying is that we have a statement inside another statement. Okay, so if we have a statement inside another statement, we call it a nested selection statement. Okay. Now, over here, look at this carefully. You can see that there is one, how do you call it? There is one if statement, one big if statement. Okay. Then the if statement has an else. Okay. So you can see that there's an else and there's an if. Okay. So it means that when we check this and it's true, okay, when we check this and it's true, we do this. Okay, but what if it is not true? If it is not true, then we go inside. Now, when we go inside the false part, you can see that there is another if statement inside the false part. Okay, so what it means is that if this is not true, then we come here. When we come here to, it's an if else statement. Okay, so it means we need to also check. We need to check. And is the balance greater than or equal to 2,500? If it is, then we set the rate or lending rate towards 5%. Okay. If it is not, then we go and do the else. Okay. So let's say it is not. Okay. So we come to the else. We see that there's another if else statement in here. We check, is balance greater than or equal to 1,000? If it is, then we do this one. But if it is not, then we do this one. Okay. So for example, what if balance is equal to 800 Ghana cedis? So if 800 Ghana cedis, what do you think the rate will be?
0.
Okay. Gentleman says 0. Who else has another opinion? Gentleman says 0, yes. Or you all agree because the gentleman says 0. Hello, do we all agree?
Yes, sir.
We all agree. Okay, that's it. Okay, so the gentleman is correct. 0 because 800 is greater, is not greater than what? 5,000. Okay, so it will be else. Then 800 too is not greater than or equal to 2,500. So it will be else. Then we know that greater 800 is also not greater than or equal to 1,000. So it will be the else. And so we'll come and we'll end up doing this one. Rate is equal to 0.00. So that will be the rate. Okay. Let me switch to the tablet so we can do some illustrations. Okay, let me stop the share. Okay. Now let's do another example. Let's go back to Zoom and then we'll do another example in whiteboards. Okay. So we want to write a simple program. Sorry, Mr. Boateng, your hand is up.
The next selection statement. That one, it deals with when the statement is not true.
Which of them are you referring to?
The nested selection statement.
Oh, you can put it anywhere, but just that you have to evaluate. So I'm going to do another example and show you. Okay.
Okay.
Yeah. Okay, so let's write a single or a simple selection statement, okay, where the selection statement is checking whether somebody is eligible to vote. Okay, remember in Ghana you have to check whether you are Ghanaian and then you are eligible to vote. Okay, so first and foremost we want to check the nationality, then we want to check the age. Okay, so we are checking two important things. So number one, we start our program. Okay. Then number 2, we declare a variable. Okay. Let's declare a variable called age. Remember, age is a number, so let's declare age as an integer. Okay. Oh, sorry. Then number 3, let's declare a variable called oh, it's going to be too long. Okay, let me just make it nation. Okay, as a string. So let's just set the variable. So we set the age equal to, let's make it maybe 21 for now. We can come and wipe it later on. Then number 5, let's set the nation equal to GH. Okay. So next thing we want to do is that number 6, we want to check if the person is eligible to vote by first checking their age. If they are 18 years, then number 7, we want to check whether if the nation is equal to GH, then we do number 8, which says right eligible. Okay, to vote. Okay, then number 9, because that's the end of this one, we put end if. Number 10, we do else. Then number 11, we write not eligible. Okay. Then number 12, and if. Number 13, then we end the program. Okay. So we have a simple program. Let me squeeze a bit so we can see it. Okay. Can we see, please? Sorry, my handwriting is not very subtle. Okay. I hope it's okay.
Yeah,
Okay.
okay, sir.
So over here in this example or sample program, if you look closely, you can see that this one is an if-else statement. It is the bigger if-else statement. Okay. Now notice that there is an if or single if statement in the true part. Where the thing is true, that is where the if statement can be put. Okay. Oh, Mr. Solomon, you're in. Stop. Please.
So it's a mistake.
Okay. Oh, can you undo the thing you did? Can you undo? Okay, Mr. Solomon, you have to undo yours. Okay. Yeah, thank you.
Okay.
Okay. Okay. So notice that we will only go and check the nationality once you are 18 years. Once this age is greater than or equal to 18 years. If the age is greater than or equal to 18 years, then we will have to now go and check your nationality. Okay? If your nationality is Ghanaian or GH, then we tell you eligible to vote. Do you understand the way we wrote it right over here?
Yes, sir.
Okay. So you can possibly do something like that. It's possible to do something like that. right? Where you can put it either at the true part or the false. In the example you saw in the slide, it was put in the false part. And even that one was an if-else statement. So you can, with the knowledge we have acquired, okay, from the single if and the dual if and what have you can write any, you can just write any of them inside any of them. It doesn't really matter. You have to write at the true part or the false part, or it has to be an if-else, or it has to be an if. It can be any of them, provided that the logic is correct. Are you with me? Yes, Mr. Prince.
Okay, so sir, I'm just asking for this simple program like this. Once we are checking for true condition, can we use the logical operator as well?
Which of the logical operators?
The end, since we are checking for the age and the nationality.
Yes, you can use the end. So you could have written it as what? If age is great. Sorry. Come in. So if age is greater than or equal to 18 and nationality is equal GH, then you write eligible to vote. Else you write not eligible to vote. Okay, then you end the if. Okay, so this one can be written also. Okay, but because I'm demonstrating nested, okay, that's why I decided to do this. But of course, you can do this, it's possible. Okay, my friend who asked the question.
Okay, sir. Thank you.
Okay, you're welcome. Any other question? Any other question? Because you really need to understand this one very well. Okay. Okay, let's go back to our presentation. Okay, so away from that, let's look at another example. So in this other example, you see that unlike the first example, where I have several if-else statements inside the big if-else statement, okay? The one outside is usually called the outer if, okay? Then the one inside is called the inner if. Then there will be another one inside called the inner if, okay? So we have the outer, the inner, and then the inner, okay? Are we okay? Hello, am I still on the call?
Yes, sir. Sir, please, we have two inner
Yes.
ifs.
Unfortunately, we don't have inner and inner. Okay, we call them inner. Okay, that's just how we call them. Okay.
Okay, sir.
Yeah. I understand you. I knew you were going to ask that question. That's why it's called the inner. It's called the inner if. Okay. That's all. Now look over here here we have an if-else statement inside another if-else statement, okay? So the outer if is here, and then the inner if is here. This if is at the true part. So remember that this one will only run when this check is true, okay? So if temperature is equal to 61, then we come and check, is temperature greater than 80? If it is not, if it is, then we write this one. If it is not, then we write this one, okay? So at 60, we'll see this one. Good day for golfing, okay? But if it were to be maybe temperature is equal to maybe 91, then at 91, because 91 is greater than or equal to 80, we will see good day for swimming, okay? Because 91 is already more than 50. Now, in the case where temperature is maybe 43, remember 43 is less than 50. So we don't run any of this one. Instead, we go and run the one down here. Good day to play tennis. Because 43 is less than 50. So this is false. So because it's false, we go and run good day to play tennis. I hope this is understood.
Yes, sir.
Yes, sir.
Okay, that's nice. Lovely. Now, sometimes we need to check multiple things. So in order to check multiple things, we have a programming construct, okay, we call the multiple alternative. Okay, what it does is that it allows us to check more than one at a time, but it will only do the one that is true. Even though we are checking more than one, only the one that is true will be done. Okay, so let's see how it works. So it looks like this. It looks like this. Okay, so we have if, and then the condition 1, then else if, condition 2, then else if, condition 3, then condition 4, condition 5, and so on and so forth. Okay, for each condition there will be a statement. Okay, each condition will have a statement under it, and that statement will only be run when the condition is true. So if this condition is true, then we run that, and then so and vice versa. Okay, then if the condition is not true, or any of the statements are, or all the statements are false, sorry, sometimes we can add the else. So there will be else with some statements in here, which will run when none of the conditions are true. Let's see some examples. Okay. So for example, this is a simple example, okay? A case where when the score is, and then the rating, okay? So for example, when the score is 10, the rating is A. When the score is 8 to 9, the rating is what? B. When the score is 6 to 7, the rating is what? C. When the score is 1 all the way to 5, the rating is what? D. Okay, so we can write it like what you are seeing over here. You can see the if, and then the score equal 10, then the rating is A. Oh, sorry. Okay, then if, else if. So notice that here we have else if on the same line following the other. Okay, so this indicates that we are dealing with something called the if else if statement. Okay, these statements, they look like what we saw earlier. Okay, over here where we have the if with the condition, else if with the condition, else if the condition, to the end. Okay, so let's go back. You can see that. Okay, so you can see that if the score is 8 or the score is 9, so whether it is 8 or 9, we will see B. Then whether it is 6 or 7, we will see what? C. Then whether it is what? 1 or it is more than 1 or less than 5, okay, we'll see D. This means that 1 is included, 2 is included, 3 is included, 4 is included, and 5 is included. Okay. Look, see this one, you see this one, okay, but you see that this one means that it is only 6 and 7. Here, this one means that it is only 8 or 9. Do we all understand what I'm saying?
Yes, sir.
Okay, that's very good. So those elementary mathematics, the less than or equal to and greater than, they are very, very important. Okay, they are very, very important. Yeah, they look very simple, but most people get flawed because they don't understand how a number is less than another number. Okay, it's very important. Okay, let's see another example. Here we are checking balance. Okay, so we are checking if balance you have is greater than 5,000. And we are also checking if balance is greater than what? 2,500. And then we are checking if balance is greater than 1,000. If all of these are not true, then we are doing the else. Okay, so let's examine it critically. Look at this carefully. Balance 1,000. Is 1,000 greater than 5,000? No. Balance is 1,000. Is 1,000 greater than 2,500? No. Balance is 1,000. Is 1,000 greater than or equal to 1,000? Yes. So we set the rate equal to what? 0.03. Remember, 0.03 is what? 3%. Do we understand the logic?
Yes, sir.
Yes, sir. Yes, sir.
Okay. That's good. Okay. Then in this example, okay, let's do an example. Let's go to the whiteboard and then we'll do an example. Okay. Okay, so let's go all the way to the top. Okay. 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 So let's write a simple program. Okay. And in our program, we want to assign grades. So we have score for an exam and then the grade for the exam. Okay. So if the score is between 100 and let's say 80, let's give the person an A. If the score is between maybe what's that? Is it 60 to I think 70, right? So 70 to 79. Remember, it has to end over here, okay? So that one will be a B. If it's between 60 to 69, that will be a C. If it's between 50 to 59, that will be a D. And then finally, 0 all the way to 49 will be an E. Okay, so let's write a program that reflects this idea. I hope we can all follow, right?
Yes, sir.
Okay.
Yes, please.
Okay, so number one, we need to start our program. Okay. Then number 2, we need to create variables. Okay, because we need to store grade and we need to store the score. So 2 variables, one for score, one for grade. Okay. So because you see, grade is letters, alphabets. So it means the variable data type is what? Character. And then score is numbers. And the numbers are not decimal. Okay, they are whole numbers. So the variable data type is what? Integer. Okay. So we declare int score, and then we declare character grade. Then we need to collect the score from the user. So number 4, we can do a prompt. Okay, so we write enter your grade. Oh, sorry. Enter your score. Okay. Number 5, we need to input score. So now we have the score inside the variable called score. Now, how do we check? Want to check. How do we check? So in order to check, we do the if statement. So I'll keep this one in place so that we can see it. So if the score is greater than or equal to 80, remember 80 is part, okay? And the gentleman was telling us that we can use the end score is less than or equal to 100. Then we do number 7, grade is equal to A, okay? Number 8, else if score is greater than or equal to 70 and score is less than or equal to 79, then number 9, grade is equal to B, okay? So character. Number 10, else if score is greater than or equal to 60 and the score is less than or equal to 69, then number 11, grade equal to C. Number 12, else if score is greater than or equal to 50, 50, and score is less than or equal to 59, then we set the grade equal to D. So we have the last one to do, okay? So the last one, it says that if it's between 0 and 49, okay? So that's 14, sorry. So else if score is greater than or equal to 0 and score is less than or equal to 49, then number 15 grade is equal to E, then 16. So we end the if statement, then 17 we can output. So we write your grade is, and we can concatenate that with what? Grade. Number 18, we can end the program. Okay, so let me squeeze a bit so we can see. Sorry about the size, okay? It's a bit difficult to show everything with the bigger size, okay? Is it a bit clear?
Yeah, it's okay, sir.
Okay, so you can see the if score, sorry. Oh. Okay, so you can see the if score, and then the else if score, and the else if score, and the else if score, and another else if score. And then finally, when we are done with all the options, we can see the output statement, okay? So we can describe this one as the process, and then we can describe the top to this point as the input, okay? So you can see the input, process, output framework. Any questions? Any questions about the if, else, if? You can also ask about the if, else statement or the if statement we learned earlier. Hello, can you hear me or I'm off?
I can hear you, sir. I can hear you.
You are not talking, that's why I'm.
Oh, okay. I can hear you, sir.
Is it okay?
It is okay, sir.
Sure.
Okay, let's do another example. Okay. So in the last example we're going to do, we want to check whether that one, I will let you write a bit of it yourself, and then we'll come together and then we'll look at it carefully, okay?
Yes, sir.
So we want to check whether a number is positive or negative, okay? Okay, so we want to check whether a number is positive or negative. So how do we go about it? I'll take contributions from you because we have some time. I'll take some contributions from you and see how your thinking is going so that we can see best how or what to correct, okay? Yes. How do we check if a number is positive or negative? What's the first thing we'll do? Oh, the person who's writing, Moses, or say, please stop doing that. Mr. Moses. Mr. Moses, stop writing on my thing, okay? Yes, please. Contributions. I'm taking contributions.
Sir,
Yes.
please, I'm just trying. Can I say positive and negative numbers, right? So
We want to check whether a number is positive or
positive and
negative.
Yeah, so can we declare a variable with positive and negative numbers? Like, I don't know how to
Oh,
put it, but
you said what? I can't hear you well.
I'm saying that um, you asked the question on how we should
Yes,
start.
yes, yes.
So,
I just want to hear you. I can't hear you well.
okay, can you hear me now, sir?
Go on, go on. I'm listening.
So I'm saying we should declare variable positive and negative numbers.
Is that a variable's name?
No, I'm saying, yeah, positive and then negative numbers.
How many variables are those? Are those two different variables or one variable?
Two different variables.
No, no. You don't need two different variables. Mr. Prince, what do you think?
Sir, so we will declare only one variable,
Okay.
and we use the if else
One variable. So when we
statement.
start,
Yes, please.
number two, we need one variable, right?
Yes, please.
We declare a variable. Let's call it num. Okay. Then
Yeah.
what we do?
And we write, we display something to the user for them to enter their number.
Yes, the prompt. Yes. Okay.
Yeah.
So we write enter a number. Okay. Then number
Yeah.
4, we collect the number. So input num. Okay. So now that we've done the input, what do we do at number 5? Who else is helping us? Who else can help us? Aside Mr. Prince. If you don't volunteer, I'll mention the name. I'll check the meeting list and mention your name. Hello?
So after inputting the number, can we say, let's say if the number is
Okay.
greater
So
than
if
0?
num is greater than 0, then
Yes. Then it's positive.
okay. Then number 6. Right? Positive. Okay. That's good. So what do we do next?
So
You
since it's
say
if and then
if the number is less than 0,
So else if.
Else.
else if
Else. Just else. Okay.
okay.
Okay. Number 8. So right. Negative. Do you get it?
Okay, yes.
Number 10. End if, and then end. Okay. Now let me pinch the bits and then show you. So the trick or the thing is that because we are checking this one, is the number greater than 0? So any number which is not greater than 0, including 0 itself, we will write negative. Okay. That's it. Once you've done that check, if the check is not multiple things, then don't use the if else if. Okay. Do we all understand? If the check is not multiple things, don't use if else if. But if it is multiple things, that is when you use if else if. So because the check is just one thing, like for example, you want to check whether a number is greater than 0, or you want to check whether a number is less than 0, then that one is one thing. So you just use if this so and so, then this one, else this one. Okay. But we can modify this. In fact, you can modify this. You can modify it so that we can cater for 0. Okay. So because 0 is not negative. Do you know that 0 is not negative?
Yes, sir.
Yeah.
0 is not negative and 0 is not positive.
Positive. Yeah.
So that one you can do if, else, if. Okay, because there are 3 things. You want to check whether num is num is greater than 0. Else, if you want to check whether num is maybe less than 0, or you want to check whether num is what? Equal to 0. So when you have 3 things like this, then you can use if, else, if. Okay? Can someone write it? Hello? Hello? Hello?
Hello, sir.
So can we say it's just a continuation of the else? If
I don't understand what you
yes,
mean.
sir. So after let's say the number 7, the 0.7.
Yes.
Okay, so let's say 0.6, that is right positive. So we come
Yes.
to the 7, that is else if num is less than 0.
So this one you can write in many ways. You can even use nested if, you can use if, else, if, you can use so many things. Okay.
Okay.
The gentleman was saying something. Can you please go ahead and then let me hear you. Let's just write the part with the if. Okay. So he said if num is greater than 0, then write positive. Okay. Else, if num is less than 0, less than 0, then write negative. Else, if it is not greater than 0 or less than 0, then it's equal to 0. Okay. So you can write 0. Okay. Like this. Or someone too can say if num is greater than 0, then write positive. Those who are writing on the thing, I don't know why you're writing on it. Please stop writing on it, okay? Else, then you can have a nested if num is equal to 0, then write 0, else write negative, and if. So here you can see I'm using a nested if and another if, and then here you see I'm using if, else, if. Okay. So you can do it in different ways. That's why we say that we are not teaching you that this is the only way to do the thing, but we are teaching you how to think about logic. So once you can think about logic, then you can design the logic any way you want to do it, which is correct. Any questions? My lecture will end somewhere here, but I want to leave room for some questions. So any questions? Next week we'll add more. Next week is a holiday on your calendar. So we're going to add more the next time we meet. Any questions? Hello? Are all 20 of us okay?
Yes, sir.
Okay. We're all okay. Okay. We all understand this and we can generate this in the future. So I want to remind us of the assignment. The assignment also uses this idea. So please go through, make sure you understand so you can do the assignments and submit in person. Okay. The course rep can make arrangements, and then those who will not be able to visit, who will not be able to come for the next face-to-face, they can have their work sent into them. But I want the work to be handwritten. Okay. These days, there's too much AI. Okay, so I don't want any typed work. I want handwritten. Okay. Are we okay?
Yes, sir, we are okay.
Okay.
Yes, sir.
So thank you very much. I'll leave you some time so you can prepare for your next class. Mr. Moses. Mr. Moses is smiling.
When you mentioned the AI,
Yes, because if they say they are going to type it and bring it to you, they are just going to copy the text directly from the AI and then just print it and bring it without even learning it. So I want you to write it with your hand. So at least you can learn something from it.
yes, sir.
Is it understandable?
Yes, sir.
Okay. But don't go and use an AI. By that I mean don't go and use an AI. Come on. I will see it when I get it that you use an AI. Okay, so we'll call it a day. Thank you so much.